All right. We left off part two at the end of part two of this lesson with derived units. Derived units are where you have two different units of measurement, and right before the bell rang, we did miles per hour. Those are two different units of measurement. Another one I want to go over with you guys is a very common one, and it is density. Density is mass over volume. And whatever unit of measurement for mass or volume you use can be different. But what is the base unit for mass in the metric system? First off, I'm glad that it was quiet. I want you guys to stop and think before you speak. So that was good. If you haven't noticed yet, I'm not one of those teachers that wants immediate instant gratification. I want you to stop and think about it, especially because you're dealing with something that's like a foreign concept to you. So good. And I interrupted you. You were saying? Grams. So grams, for instance, over what's the measurement for volume? It could be cubic centimeters. I haven't gone over that yet, Varun. You're thinking of something I haven't done yet. Just liters. Let's stick with liters for now. Now, not only could it be grams over liters, can you think of some different iterations or measurements of grams? Like, what do you call 1,000 grams? Yeah, you could do kilograms, kg over liters. That would be okay. What do you call 1/1000th of a gram? A milligram over maybe a milliliter. So any sort of gram over liter, this is a derived unit. I'll give you one more, and then we're going to go to this worksheet that I have for you. The speed of light. Is 3.00 times 10 to the 8th m over s. Can you tell me what that is? What's the m? Not minutes. We never done minutes in here. Yeah. Meters. And what's the s? Seconds. Now, do you guys know what to say when you see this division symbol? This is one of those little teeny tiny things that you may not know, but I want you to definitely know. What do you say if you're driving and you're going miles blank hour? What do you say? Per. P-E-R. Whenever you guys see that, I need you to say per. Sound like a cat. That's just one of those little ticky-tacky things I need you to know. Here's one more, and I actually did this with my AP Bio kids the other day, and they were a little confused. It's been a long summer. Later this school year, like a long time from now, I'm going to teach you something called specific heat. And the unit of measurement for specific heat is actually a derived unit. I have not gone over this one unit of measurement yet, so if you don't know it, it's okay. But if you do know it, please speak up. Do any of you know what J stands for? Joules. This is energy. You know what G stands for, right? Grams. And what is that degree C? Celsius. Great. Now, what do you say when you see this division symbol? Per. Nice. And here's where they were confused in my AP Bio class, my college level class. What do you say when you see the multiplication symbol? Exactly. They were confused too. You also say per. So you say per with division, you say per with multiplication. So could anyone maybe have the courage to say this whole derived unit for me? I want someone who's not raising. Gator bait.
Joules per gram per degree Celsius.
That's it. Joules per gram per degree Celsius. Got it. All right. So now that I've gone over a lot of this introductory stuff with you guys, what I recommend that you do for today is that you have this chart somewhere on standby. This is not a test. You're allowed to look at your notes, but here's my philosophy with this. The less you have to look at your notes, the better you should feel about your understanding of it. But if you need to take a peek, take a peek. Your test is until next week, I believe. So keep that in mind. So have that chart on standby. Let's go over a few of these. This is a worksheet I passed out to all of you. There are 15 problems. You're asked to convert one unit of measurement to another. So I'm going to do a first couple with you. Maybe just the first one. And as I was saying at the beginning of class, I was trying to think of a way for you guys to try to remember which units are bigger than others or smaller than others. So I was thinking how we weighed myself the other day. Maybe this, and this is actually just an experiment for me, maybe this will help you remember metrics. Okay? I want you to write my name on your notes. And I want you to write how much I weigh in kilograms. I weigh 99.7 kilograms. I want you to be able to convert that to grams. Now, is a gram smaller than or bigger than a kilogram? Smaller. How many times smaller? 1,000. Very good. Now, if I'm going to go from kilograms to grams, listen, will my number for grams, the number be bigger or smaller? So it's going to be less than 99? It's going to be bigger. Because we're going from kilograms to grams, you need to add 3 zeros to the end. So here's what you do. Here's 99.7. You're going to go 1, 2, 3. That's where your new decimal is going to be. So I am 99.7 kilograms or 99,700 grams. I want to do one more with you. I'm trying to see if this kind of tactic helps. So you guys be the judge. You tell me yes or no if this is helping you. I want you to measure me in milligrams. Look at your chart if you need to. Is a milligram bigger or smaller than a gram? Smaller. How many times smaller? 1,000 times smaller. So will my number 99,700, will that be bigger or smaller if I'm going from grams to kilograms, or sorry, grams to milligrams? Bigger. How many times bigger? How many zeros do I need to add to this? 3. So here's 99,700. My decimal is right there. Shift it to the right 3 more. 1, 2, 3. There's my new decimal. So what is my weight in milligrams, everybody? 99,700,000. What do you suppose is easier for a doctor at the hospital to do? Write down, oh, Kurt Thorson is 99,700 milligrams, or Kurt Thorson is 99,000. Oh, wait, did I say that right? 99,700,000 milligrams, or 99,700 grams, or 99.7 kilograms. What do you think would be easier for them? The kilograms. Easy. So let's see if that might help you with a few of these. Let's go to number 1. 5 meters to kilometers. All right. What is bigger, a meter or a kilometer? How many times bigger is a kilometer than a meter? 1,000 times more. So here's my 5. Do you need to shift the decimal to the right or to the left in order to make this number smaller? How many spaces?
3.
How did you know? There are students in this room that do not know how you got 3. So how many times bigger is a kilometer than a meter? 1,000 times. How many zeros are there in 1,000? 1, 2, 3. 0.005 kilometers. If you ran 5 meters, that's like going from one end of these desks to the other. That's roughly 5 meters. Probably a little bit more than 5 meters, but approximately. Let's check out number 2. 3 grams to milligrams. Is a milligram bigger or smaller than a gram? How many times smaller? 1,000 times smaller. So do we need to shift the decimal to the right or to the left 3 times? How many spaces? 1, 2, 3. $3,000 milligrams. I'm going to skip 3. I'm going to go to 4. And then I'm going to let you guys work together if you would like to. And give you about 10 minutes to work on this. This is where it gets kind of tough after number 3. 1, 2, and 3 are warm-ups. Okay. Here, I'm going to give you a strategy. It's you guys are getting to be your sophomores, some juniors. I just want you to get the answer. If you want to use this, you can. I'm not going to force you. I would encourage you to go from milligrams to grams first, and then go from grams to kilograms. Or, yeah, kilograms. But it's up to you. What am I doing? Okay, whoa. That's a typo. On number 4, cross out the KM and put KG. That's a typo. That's wrong. What? Pass this back to her, please. Sorry. Okay, so what I would suggest you do is you go from milligrams to grams, grams, kilograms. Some of you might not need to do that. Eventually, I want you all to not have to do that. So let's just take one at this step first. I have 60 milligrams. I want to convert it to grams. Is a milligram bigger or smaller than a gram? A milligram is smaller. So when we're going from milligrams to grams, here's my decimal right there. Do I need to shift my decimal to the left or to the right in order to convert milligrams to grams? Oh, I hear both. So we need to have something to refer to. When converting to a larger measurement, shift left. When converting to a smaller measurement, shift right. That might help you guys. So let's start this over. You're going to go from milligram to gram. Is a gram bigger or smaller than a milligram? Bigger. Very good. How many times bigger than a milligram? 1,000 times. How many zeros are there in 1,000? 3. So we're going to bigger or larger. Do we need to shift the decimal left or right? Answer that first. Left. How many times? Why? Let's take now. There's 2 parts to this. You're saying shift to the left 3 times. I guarantee you there are people in this room that don't know why you're shifting left, and there are people in this room that don't know why you're doing it 3 times. So let's cover that. Why are you going to shift it to the left? Who could please help us? Yes. You are converting to a larger measurement. You're going from milligram to gram. That's why we're going left. Now, why are we shifting 3 spaces? Why 1,000? Where did you get 1,000 from? I'm new at this. A milligram is 1,000 times smaller than a gram. There are 3 zeros in 1,000. So 1, 2, 3. Your new number is 0.060. But that's just halfway there. We now need to go to kilogram. What is larger, a kilogram or a gram? A kilogram. So we're going bigger. Do we need to shift our decimal left or right? Look at what I wrote on the screen. Left. Now, next question. We got left. Good. We're going left. How many times bigger is a kilogram than a gram? 1,000 times. How many zeros are there in 1,000? So you take your number, 0.06, shift it 1, 2, 3. There's your new decimal. Fill those blanks in with zeros. Your new number is 0.00060 kilograms. Okay, guys, I gotta let baby birds try to fly on their own. I'm gonna set my timer for 10 minutes and then see where you're at. You may work together if you like. Try to complete this whole worksheet. If you want to do the strategy I just suggested, you're more than welcome to. I'll be around to help you if you need me. 10 minutes. I'm going to pause the video right now. All right. Okay, it's been about 7 or 10 minutes. Let's see if you guys can get the rest of them. Check your work, please. 7 meters to centimeters. A centimeter is smaller than a meter, so we're shifting to the right. A centimeter is 100 times smaller than a meter, so you're going to have the 7, and you're going to shift it 2 to the right. So it will be 700. 2.5 meters to millimeters. A millimeter is smaller, so you'll be shifting to the right. A millimeter is 1,000 times smaller than a meter, so you need to shift the decimal 3 times to the right. So 2,500 or 2,500. Centimeters to kilometers. Oh boy. Maybe you wanted to shift to meters first. That would be 0.04 meters. And then you would shift it 3 more times to the right. So this is a total of 5 shifts to the right. If you want to know where I got 5, it's because a centimeter is 100 times smaller than a meter. So there's 2 zeros. And then a kilometer is 1,000 times bigger than a meter. So there's 3 more. I'm shifting 5 times to the right. So it should be 0.000. 1, 2, let me see. 1, 2, 1, 2, 3. Yep, 4 zeros. So I had to make sure. All right, 77 meters to decimeters. You're going smaller, so you're shifting to the right, and you're only shifting to the right by 1 because a decimeter is 1/10 of a meter, and that's 10 has 1 0, so it should be 770 decimeters. Next is decimeters to millimeters. A decimeter, here's where I want to try to change your thinking up. A decimeter is 1/10 of a meter. A millimeter is 1,000. How many zeros are there in 10? How many zeros are there in 1,000? What's the difference between 1 and 3? 2. So you shift the decimal 2. And you're going smaller, so 2 to the right. So it should be 3,700. Now we have 0.002 centimeters to millimeters. We're going smaller. So you shift the decimal 1 to the right. So it should be 0.02 millimeters. 44 millimeters to meters. You're going bigger. So you're shifting to the left. 3 spaces. Because a millimeter is 1,000 times smaller than a meter. 1,000 is 3 zeros. So 0.045 meters. Kilometers to meters. You're going smaller. You're going to be shifting to the right 3 times because the kilometer is 1,000 times bigger. So 2,500. Oh, wait, 1,000. 25,000 meters. 880 meters to centimeters. You're going smaller. You're going to shift to the right 2 spaces because 100 is 2 zeros and a centimeter is 100 times smaller. So you got your 880, then add 2 more zeros. Okay, 3 more. Kiloliters to deciliters. Okay. How many times bigger is a kiloliter than a liter? 1,000. Good. So how many zeros is that? 3. And then how many times smaller is a deciliter to a liter? 10. So there's another 0. So how many total shifts are you doing? 4. 1. Oh, not there. 1, 2, 3, 4. 1, 2, 3, 4. Yep. 95,000 deciliters. 66 decimeters to decameters. All right. This should be a total of 2 shifts. You're going bigger, so it should be 0.066 from deciliters to, or decimeters to decameters. Did I do that wrong? You're right. 0.66. My fault. All right, 5 liters to hectoliters. How many times bigger is a hectoliter than a liter? 100. How many zeros is that? Okay, so 1, 2. 0.05. Now, you guys are not going to believe the words. I can't believe the words that are going to come out of my mouth, but you guys are learning this, and I empathize with that. I know I just went over this with you, but the fact that you did this, I can't believe I'm going to say this. You'll get participation points for this. I normally don't do that. But when you walk out of here today, place that in the box, and I can give you a grade for that, okay? All right, now, let's get to the next lesson I have for you on this topic. And it has to do with scientific notation. And this is what your assignment will be tomorrow. If you look at the calendar, it says I won't be here. Next time I see you guys is Monday. So you're going to have a substitute. If you finish this assignment I'm going to give you in class, and you turn it into the box and you have no homework. But if you don't finish it, then you need to turn it in. So let's get into this. You are now going to learn scientific notation. Go back to your notes now. No, it's still part of 1.13. Scientific notation is a means of managing extraordinarily large and small numbers. Numbers that can be so huge, it's like incomprehensible, or numbers that are so small, they're incomprehensible. So I have 2 examples to give you guys. Let's see if you can do this. Rather than give it to you. I want you to see if you can write down 460 sextillion. Can you do that? Start from the top, hundreds, thousands, millions, and see if you can get to 460 sextillion. I'll give you like 30 seconds, and then I'll help you out. Yes. You clearly know what you're doing. That's good. Not everybody's on your level. You're sitting there like, this isn't even my final form. We'll get there, but it will be 4 point something to the something power. All right, here we go, guys. Here's how I would do this if I were you. Just start from the top. Hundreds, thousands, millions, billions, trillions, quadrillions, pentillions, sextillions. There is such a thing as septillions, octillions, nontillions, blah, 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 blah. That is an outrageously big number. Way too complicated. I'm going to show you how to make this far more manageable. So step one. If no decimal is present, add one. Okay? Decimal, right there. Next, I need you to shift the decimal as many places as necessary so that you end up with the number between 1 and 9.9. All right, let's just say 1 and 10, okay? Step two. Shift the decimal as many places as necessary to have a number between 1 and 10. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm going to write 23 in the side somewhere. So I got that. So I end up with 40 or 4.6 times 10 to the 23rd power. When you are making a huge number like 460 sextillion, 4.6, you shifted the decimal to the left. That's positive. Sometimes students' brains go straight to a number line that you learned in 3rd grade. You got 0 in the middle. If you go to the left, it's negative. If you go to the right, it's positive. Don't go there. When you shift left, you're going up. You're going positive. I can't make it any clearer than that. So let me give you something a little more manageable. Look back up here. I want you to put 3,000 milligrams into scientific notation, like what you did on number 2. Can you do that? Please put 3,000 into scientific notation. What would it be? Why'd you say negative? Look what I wrote down here. It's okay, you're learning. When making a larger number smaller, the exponent is positive. If you shift the decimal left, you're positive. So the decimal is right here. We're shifting it 1, 2, 3 places to the left. So it's going to be 3.0 times 10 to the what? Positive 3. And don't forget to write milligrams. Can you do that one now? What would that be? You probably do it in your head. Yeah. Number 8.
times 10.
Good. Millimeters. Do number 11. Meters. Do number 12. Good. One more. Number 13. Deciliters. Good. Okay, now let's do the opposite of this. Let's say you're taking something super small and you want to make it a little larger and manageable. Here we go. Whew, that's painful. That's a lot of zeros. I'm not going to tell you how many. I know your eyes might get lost. We'll work this out. So with this one, shift the decimal as many times as necessary to get a number between 1 and 10. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I have 2.0 times 10 to the, now we shift to the right. So what can you assume? Negative. Shift right. You have a negative exponent. So let's do one that's a bit easier. Look at your worksheet. Varun, can you place number 6 into scientific notation, please? One, 2, 3, 4. That would give us 0.4. 10 to the negative 5. Good. Kilometers. Is there another one here? Ooh, Varun, do number 4. One, 2, 3, 4, 5. Correct. And that would be kilograms. Okay. Got a few more minutes here. I want to show you guys what to do when you're adding and subtracting scientific notation. This will get you set up for your worksheet. I got about 4 minutes, so I got to get this out to you. When you're adding and subtracting, the exponents must be the same. So if I have 7.35 times 10 to the second meters plus 2.43 times 10 to the second meters, you first have to ask yourself, fourth period, are the exponents the same? Are they? Yes. So bring that down. Your answer will be 10 to the second, and then just add the coefficient. These numbers here are called coefficients. And this is where I'm serious. You got second grade math now. 5 plus 3 is 8. 3 plus 4 is 7. 7 plus 2 is 9. 9.78 times 10 to the negative 2. Now I'm going to throw you a curveball. 7.35 times 10 to the second. 2.43 times 10 to the fourth. And you're adding. You have a choice. And whatever choice any of you make, you'll end up with the right answer. you can choose to make 10 to the second up to 10 to the fourth, or 10 to the fourth down to 10 to the second. What do you want to do? Do you want to turn this to 10 to the fourth? Or do you want to turn this into 10 to the second? What do you want to do? You want to turn the 4 into the second? Okay, you can do that. So guys, here's what you do. I need to get that 10 to the fourth down to 10 to the second. So if we want to make it 10 to the fourth, 10 to the second, are we going to increase or decrease? Are we going to become more positive or more negative? We need to get down to 10 to the second. Negative by how many? Now, if we want to get it from 10 to the fourth down to 10 to the second, do we need to shift the decimal 2 to the right or 2 to the left? Look back up here. Shift right, you go negative. Shift left, you go positive. So do we want to shift 2 to the right or 2 to the left? I heard left and I heard right. You're going from 4 to 2. Are you adding or subtracting? You're subtracting, you're going negative. So we need to shift the decimal 1, 2 to the right. And that will turn your 10 to the fourth into 10 to the second. So you'll have 243 times 10 to the second. And so now you'll have 243 plus 7.35. That's going to give you a 500.35 times 10 to the second. But you're not done yet. And I'm going to be saying this a lot this year. Do you right now have a number between 1 and 10? No. You need to make it between 1 and 10. Before you go, shift it 2 to the left. 5.0035 times 10 to the
7.25 plus 248 is 500.
What'd I do? I added it wrong. What, 243 plus 7? That's 250. That's 250. I'm sorry. 250.35. All right.